video, we are going to explain to you about Ethernet protocol, standard Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. There are two Ethernet protocols. They are IEEE Project 802 and Ethernet Evolution. IEEE Project 802 started in 1985 by the Computer Society of the IEEE. It was created to set standard to enable intercommunication among equipment from a variety of manufacturers. This image shows the relationship of the 802 standard to the TCP/IP protocol suite. Project 802 does not seek to replace any part of the OSI model or the TCP/IP protocol suite, but instead, it is a way to specifying function of the physical layer and the data link layer of the major LAN protocols. Next is the Ethernet evolution. The Ethernet LAN developed in the 1970s and already go through 4 generations. Let's check out all of these 4 generations. The 4 generations are standard Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. Let's go through the Ethernet evolution one by one.
Standard Internet. Although most implementations have moved to other technologies in the Internet evolution, there are some features of the standard Internet that have not changed during the evolution. The characteristic can be shown with this frame. In this frame, it has preamble, SFD, destination address, source address, type, data and pending, and CRC. Preamble and SFD are the physical layer header. Preamble contains 7 bytes, while SFD contains 1 byte. Destination address, source address, type, data and padding, and CRC are the frame length that contains 64 bytes, which has 6 bytes for destination address, 6 bytes for source address, 2 bytes for type, minimum 46 bytes and maximum 1500 bytes for data and padding, and 4 bytes for CRC. Addressing. Each station on an internet network, such as a PC, workstation, or printer, has its own network interface card (NIC). The NIC fits inside the station and provides the station with a link layer address. The internet address is 6 bytes, normally written in hexadecimal notation with a colon between the bytes. For example, the following shows an internet MAC address: 4A:30:10:1 10:1A. Unicast can be declared as 0 and multicast can be declared as 1. These are the examples of how the implementation of standard Internet. Here, we have a LAN with a bus topology using a coaxial cable and a LAN with a star topology using a hub. Access method. The network that uses the standard Internet protocol is a broadcast network, so we need to use an access method to control access to the sharing medium. Next is efficiency of standard Internet. The efficiency of the Internet is defined as the ratio of the time used by a station to send data to the time the medium is occupied by this station. The efficiency of standard Internet is measured with Implementation. The standard internet defined several implementations, but only 4 of them became popular in the 1980s. This table shows a summary of standard internet implementations, and this how encoding works in a standard internet. Here are 10 base 5 implementations that using thick coaxial cable with the length of 500 meters. This the example of 10 base 2 implementation using thin coaxial cable with the length of maximum 185 meters. Next are the 10 base 3 implementation using 2 pairs of UTP cable, and here are 10 base implementation using 2 fiber optic cables.
Changes in the standard Ethernet. These changes has opened the road to the evolution of the Internet to become compatible with other high data rate LANs. These changes including these aspects: sharing bandwidth, bridging, collision domains, switched Ethernet, and full duplex switched Ethernet. In collision domains, the domains can be connected with a bridge. In switched Ethernet, the domain can be connected with a switch. And in full duplex switched Ethernet, node can be transmit and receive data using also a switch.
The next evolution is fast internet. In 1990s, internet increasing the transmission rate to 100 megabits per second, and they call this generation the fast internet. The designers needed to make it compatible with the standard internet, so the MAC sublayer was left unchanged. But the feathers of the standard internet that depends on the transmission rate had to be changed. Access method. As we know, the proper operation of the CSM ACD depends on the transmission rate, the minimum size of the frame, and the maximum network length. If you want to keep the minimum size of the frame, the maximum network length should be changed. In other words, if the minimum size of the frame is still 512 bits and it is transmitted 10 times faster, the collision needs to be detected 10 times sooner, which means the maximum length of the network should be 10 times shorter. Physical layer. To be able to handle a 100 megabits per second data rate, several changes need to be made at the physical layer. The picture and the table shows the encode and the implementation of the fast internet.
Gigabyte Internet. The need for a higher data rate have created Gigabyte Internet Protocol 100 megabyte per second. The IEEE community calls it the standard 802.3z. The goals of the Gigabyte Internet were to upgrade the data rate of 1 gigabyte per second but keep the address length, the frame format, and the maximum and minimum frame length the same. MAC sublayer. The main consideration in the evolution of Internet was to keep the MAC sublayer untouched. However, to achieve the data rate of 1 gigabyte per second, this was no longer possible. There's two distinctive approaches for medium access in Gigabyte Internet: half duplex and full duplex. Almost all the implementation of Gigabyte Internet follow the full duplex approach, so we mostly ignore the half duplex mode. Physical layer. The physical layer in Gigabyte Internet is more complicated than the standard or fast Internet. As you can see here, the implementation of 1000 base XX, LX, and CX have the same encoder, that is 8D/10B plus NRZ, while 1000 base T use 4D PAM5. And the last one is the 10 GB Internet. In recent years, the Internet for use in metropolitan areas have been upgraded. The idea is to extend the technology, the data rate, and the coverage distance so that the internet can be used as LAN and MAN, which is Metropolitan Area Network. The IEEE community created 10 GB internet and called it Standard 802.3AE. Implementation: 10 GB internet operates only in full duplex mode, which means there is no need for contentation. CSMA/CD is not used in 10 GB internet. The four of the most common implementation are 10G base SR, 10G base LR, 10G base EW, and 10G base X4. Here are the summary of the 10 GB internet implementation. Okay, so that's all the topics we have in chapter 12. Hope you guys remembered and didn't get confused with the evolution generation. Thank you for watching. Bye-bye.